This is Mr. Bouchon with Lake Central's Unit 3, Section 6 of Algebra 1, slope-intercept form. Slope-intercept form can be a very useful tool in Algebra 1. It can be used for multiple things, including graphing lines and writing equations. Basically, slope-intercept form is obtained by getting the y by itself. And when we do, we'll end up with the general form of slope-intercept form being y equals mx plus b. So let's discuss what these variables mean. M stands for the slope, and as we were discussing last time, slope tells you how steep the line is. It's a number. The bigger the absolute value of the number, the steeper the line is going to be. B is the y-intercept. Tells you where it crosses the y-axis. Now, x and y are all of the coordinates of all the points on the line. Now, there is only one slope. I have a number for it. The line can only, rephrase that, the function can only cross the y-axis in one place. I'll have a number for it. But there's an infinite number of points on the line, so that's the reason why we can't list all of them. There's an infinite number. Well, to practice solving for y, in number 1, we have 3 terms here. I have a 3x, I have a y, and I have a 10. I need to get the y by itself, and I need to eliminate this term, the 3x, from this side of the equal sign. To do that, we subtract 3x. To get it into slope-intercept form, we're going to have y is equal to whatever the x term is right after the equal sign. So it's a negative 3x. Since the 10 is positive, we'll put plus 10, and we now have this in slope-intercept form. Subtract 5x. Now, if you're thinking add 5x because of the minus sign, keep in mind that the minus sign goes with the y. The 5x is positive, so you subtract 5x from both sides. That leaves you with the opposite of y is equal to negative 5x plus 6. What you'll do next is divide by the coefficient negative 1, the coefficient of y. You'll divide by negative 1 and get y is equal to 5x minus 6. This is now in slope-intercept form. Subtract 8x from both sides in number 3. It gets you 2y is equal to negative 8x plus 10. Dividing everything by 2. Y is equal to negative 4x plus 5. And in number 4, you're going to subtract 2x from both sides. Again, that 2x is positive, so you need to subtract it in order to get it across the equal sign. Leaves you with negative 3y is equal to negative 2x minus 6. Now, to get the y by itself, we're going to divide by its coefficient, negative 3. Gives you y is equal to 2x over 3 plus 3. Now we need to name the slope and the y-intercept in each of the following. In order to do that, we have to have the equation in y equals mx plus b form, slope-intercept form. So here it is already in slope-intercept form. M, being the slope, is the coefficient of x. In this case, it's 2. The y-intercept, b, is negative 3. In number 2, we have to subtract x from both sides first. So I need to go minus x on one side, minus x on the other side, and I have y is equal to negative x minus 4. Since the coefficient of x in this case is negative 1, the slope is negative 1, b, the y-intercept, is negative 4. In number 3, I have a positive 3x, so I'm going to subtract 3x from both sides. Negative 4y is equal to negative 3x plus 12. Divide everything by negative 4. And I have y is equal to double negative is positive, so it'll be 3x over 4 minus 3. Now, which brings me to this point also, is what's the difference between y is equal to 3x over 4 minus 3 and y is equal to 3/4 x minus 3? These two equations are exactly the same. The slope is 3/4 and the y-intercept is -3. And like we were saying above, we can also write equations in slope-intercept form as well. And to do that, the slope will be the coefficient of x. So y is equal to 8x, the y-intercept, -3 minus 3. In number 2, y is equal to 2x plus 6. And in number 3, y is equal to -1/2 x plus 5, or just the opposite of x over 2 plus 5. Let's look at number 4. Now, we were discussing the other day about how slope can be derived by using rise over run. And to do that, I'll pick any 2 points where we could figure out the coordinates, say -3, -5, and let's go to 3, -1. When I know those 2 points, I can figure my rise number, which in this case would be 4. My run number would be 6, and I reduce that fraction, so my slope is 2/3. So I'm going to have y is equal to 2/3 x, and then we look at to see where the line is crossing the y-axis. It's at -3. So the equation of this line is y is equal to 2/3 x minus 3. Doing the same thing for number 5. My slope being rise over run. If I were to take say, the point 3,2, that's where it's crossing the line. That's where this line meets a coordinate, is at 3,2, and then also maybe at -3, 4. I can figure my rise being +2, my run being -6. When I reduce that fraction, I always put my negatives in the numerator, -1/3. Where does this thing cross the y-axis? At +3. So we would have y is equal to -1/3 x plus 3. Another way to write this, by the way, would be just the opposite of x over 3 plus 3. So how do you graph lines using slope-intercept form? 4 simple steps. Make sure the equation is in slope-intercept form, meaning make sure you have y equals mx plus b. Second thing you'll do is plot b on the y-axis. Why? Because this is the y-intercept. From there, we'll use the slope, rise over run, we're going to be using rise over run, to plot more points. And from there, you can draw the line. So how does this play out? Well, I have y is equal to 2x minus 1. The slope is 2. The y-intercept is -1. But how do we get rise over run out of 2? Well, we make it, if we don't have a fraction, we make it a fraction. 2 is the fraction 2 over 1. So my rise is 2, my run is 1. Where do we start? All right, if we have it in slope-intercept form, we're going to plot b on the y-axis. So we're going to go to, here's 0, -1 is right here. That's 1 point. From there, I'm going to rise 2, right 1, and that puts a point here. I'm going to follow that pattern all the way up the page. Rise 2, run 1, rise 2, run 1. I can also go the opposite direction and go down to left 1 and down to left 1. From there, I'll draw my line. Make sure you take your line all the way across the graph, and please use a straight edge, as we want to be as precise as possible. Number 2, 3x plus y is equal to 5. Well, do we have this in slope-intercept form? No, we've got to subtract 3x from both sides so that we end up with y is equal to negative 3x plus 5. What's our fraction for the slope? Negative 3 over 1. We're starting at positive 5, though, on the y-axis. That would be here. Down 3, the 1 is positive. So it's down 3, right 1, and follow that pattern all the way down the page. Draw your line. Number 3. Do we have this in slope-intercept form? No, we're going to have to subtract 2x from both sides. The opposite of y is equal to negative 2x plus 3. Now we have to go through, though, and divide everything by negative 1. We get y is equal to 2x minus 3. The slope is 2 over 1. I'm starting at negative 3 on the y-axis. Rise 2, run 1. And draw your line. Again, using a straight edge, please, and take your line all the way across the graph. Number 4, 3x minus 2y is equal to 8. First thing we need to do is subtract 3x from both sides, leaving us with negative 2y is equal to negative 3x, and that's a positive 8, so plus 8. Dividing everything by negative 2. We get y is equal to 3 halves x minus 4. That means we start at negative 4 on the y-axis, here. Rise 3, run 2. Here's my rise number, here's my run number. So I'm going to rise 3, run 2, rise 3, run 2. Follow that pattern all the way up the page. That'll make a better line for you in the end. And take your line all the way across the graph. Keep this one in mind, class. X equals 4 is a vertical line. X equals 4 is a line, and it is vertical. And it's a vertical line at x is equal to 4. Where is x equal to 4? Here. On the x-axis, you go to 4. Make a vertical line. And if x equals a number is vertical, what's y equals a number? This will be a horizontal line. At what? Y equals negative 3. Well, here's your y-axis. Where's the y equal to negative 3? Here. Make a horizontal line, and you've graphed that one. So that's it on this lesson on graphing and writing equations in slope-intercept form. Thanks for listening, and we will do this again next time.